So now for this third video in section 3.1, we are going to look at working with these quadratics in a different form. So let's just back up a second. We just worked on graphing quadratics that were in the, I'll call it the HK format, where you could pick up your H and pick up your K for your vertex. So we just worked on some of those. So now let's work on quadratics that are in this other format, the ax squared plus bx plus c format. We're going to use the exact same steps that we used with the previous format with respect to finding the x-intercepts and y-intercepts, but the vertex is found differently. To find the vertex, we're going to work from the values of a, b, and c. So the x-coordinate of your vertex is found by constructing this little expression. And it says negative b over 2a, the negative in front, but I usually just write it as negative b over 2a. Means the same thing. So to find the vertex, I'm going to get my value of b from my equation and take the opposite of it, negative b, and divide it by 2 times a, which is the initial coefficient on the x squared. Once I find this value, I'm just going to plug it back in place for x to find his y value. So negative b over 2a, find it, plug it in, and find the y value. And that's how we'll find the vertex for quadratics in this format. So let's take a look at this guy right here. Minus x squared plus 6x minus 8. There is our quadratic function. So we need to determine how does it open. And remember, it's based on this leading coefficient. And since that leading coefficient is a negative 1, the negative tells me it's going to open down and that the vertex is a maximum. All right, got that. Let's find the vertex. So it's not in the HK format, so I need to calculate negative b over 2a. So in this case, b is positive 6, so I'll have negative 6 over 2 times a, and a is a negative 1. A is that leading coefficient. So I get a negative 6 over a negative 2, which is a positive 3. So that's the x-coordinate for my vertex. Now let's find the y-coordinate. And to find the y-coordinate, we plug in the 3 everywhere we have an x. So I'll have a negative 3 squared plus 6 times 3 minus 8. Be careful, that negative is separate from that 3 squared. So find that value. Well, that value comes out to be 1, which gives us a vertex of 3, 1. So over here, my vertex is over 3, up 1. There is my vertex. I'll just mark it with a V. And this guy is opening down, which means I've got x-intercepts to find and I have that y-intercept to find. So let's work on the y-intercept. And remember, we find that by letting x be equal to 0. So I'll have a negative 0 squared plus 6 times 0 minus 8. So 0 plus 0 minus 8 is a negative 8. So the y-intercept is at 0, negative 8. So down here is my y-intercept. Finally, let's find the x-intercepts. And those are found by setting your function equal to 0. Now, this is where we have to deploy our methods of solving quadratic equations. Do I use the square root method? Do I factor? Do I use the quadratic formula? Well, first thing I'm going to do is I notice there's a, with these guys that have three terms, you can always use the quadratic formula. But I actually think this one can be factored. So I'm going to put it in a format where I can factor it. I don't like having the x squared term with a negative in front. So I am going to actually just multiply everything by -1 to give me x squared minus 6x plus 8 equals 0. Then I'm going to try and factor it. Now, if it doesn't factor, you jump into the quadratic formula. But to get an 8, I could multiply 4 times 2. If they're both negative, they multiply to a positive 8. And if they're both negative, they add up to a negative 6x. So it does factor. And remember, once it's factored, you set each factor to 0. So I'll get one number to be 4. That's one of my x-intercepts. The other x-intercept is at 2. So let's see if that makes sense. Right here is 4. Right here is 2. So yeah, it looks like everything is lining up. Let's connect our dots. And we have graphed that quadratic. And remember, since it opens down, the vertex is a maximum. And we could check our work on our calculator. Go to y equals, type it in, press graph, and that looks like our picture. We could go to the table and see if we have x-intercepts and y-intercepts at those values. 0, -8, that matches. Then I have what? 2, 0 matches there. And then 4, 0 matches there. So everything matches up. Let's check this next one out. Don't want to graph it. All I want to do is find the vertex for that quadratic function and determine if it is a maximum or minimum. So let's find the vertex. And since it's in this format, which is not the HK format, I need to use -b over 2a. So -b would be -16 over 2 times a, which would be 2 times 4. So -16 over 8 would give me a -2. So there is my x coordinate for my vertex. Now I need to find my y. So I'm going to plug in the -2. 4 times -2 squared plus 16 times -2 plus 1,000. That's going to give me my y coordinate. And that tells me exactly where the vertex occurs. Now, you tell me, is this vertex a maximum or a minimum? How do you know? Well, it depends on how it opens. Since the front number is a +4, it's going to open up. And when you have a parabola that opens up, that vertex is at the very bottom, at the very bottom, which means it is a minimum. So find this value, and that is your y coordinate. So the y value of that vertex is 984. Now let's look at some applications. I have emphasized determining if the vertex is a max or a min. That's important because in our applications, they will be asking us to find a max or a min, a maximum height, maybe a minimum cost. And when you're asked to find the max or the min, all you have to do is find the vertex. And remember, to find the vertex for this format, then all we need to do is find -b over 2a and then plug that in to find his partner. So we've got this situation. The path of a baseball after being hit is modeled by this quadratic equation. and it represents the height of the baseball. And X is a horizontal distance from home plate. So how far from home plate it is and how high it is. And we want to find the maximum height. That just means we need to find a vertex. So let's work on finding it. How do I find it when I have an A, B, and C? I'm just going to do negative B over 2A, which will be negative 1 over 2 times negative 0.0032. So there's my negative B over 2A. Let's calculate it. So I calculated negative B over 2A to be 156.25. Then I plugged that number back into my function to find the y-coordinate of the vertex. When I do that, I get 81.125. Now, let's interpret this value. What does X represent? X is a horizontal distance from home plate, and it's in feet. Okay, so the ball is hit. It reaches its maximum height when it's 156.25 feet from home plate. What is that maximum height? Well, the maximum height that it reaches is 81.125 feet. So if you can find the vertex, then you can work these applications when they're asking for a max or a min. Now, I did put that one in my calculator under y equals, and I graphed it in Zoom 6, and that's all I saw. So let me show you what you can do. Hit the zoom out feature. Press enter and enter again. Enter again. Enter again. It keeps zooming out. Now I see my parabola. So I could actually go to second calculate, choose that maximum feature, and do the left bound, right bound thing. Pass it up for the right bound, press enter, and there we go. That's the vertex we found by hand. Let's check out this last application. We've got a function that models the number of accidents, motor vehicle accidents, per 50 million miles driven for drivers that are X years old. And the years, the value of X, the domain, is restricted between 16 and 74. That would be the age of the drivers we're going to consider for this model. The question is, what is the age of the driver having the least number of car accidents, and what is that minimum number of car accidents? So the word least and the word minimum tell me we're finding the vertex. How do I find the vertex? Actually, before we find it, I am curious. Why don't you sit and think about it? Between the ages of 16 to 74, what age do you think has the minimum number of car accidents? I bet the answer is going to be around in the 40s. That's my guess. I'm going to say someone in their 40s would have the least number of car accidents. But let's actually find it out by calculating negative b over 2a. So I have a negative 36 over 2 times 0.4. So that'll be 36 divided by 0.8. Make that calculation. When you make that calculation, it comes up to be 45. And remember, 45 is my X value, and that represents the age of someone having the least number of car accidents. Remember early I guessed it would be someone in the 40s, so it's actually 45. So 45-year-olds, 45-year-old drivers have the least number of accidents. If I wanted to find how many accidents that would be, then I would plug in the 45. Oops, that's not an X, that would be a 45. Plug in 45, and I could find what that least number of accidents would be. So I'm going to wrap this up. I'm not going to bother with that last example because there's actually a problem somewhere with a sign and the answer doesn't come out right. So anyway, I will stop 3.1 with this. If you've got any questions, let me know.